Okay, so what's all this about the p-series with regards to convergence or divergence of a series? So the series of this form, n equals 1 to infinity, which looks like this, where your denominator has a power p, you can know if this converges or diverges based on the value of p. So if p is less than or equal to 1, you know that this diverges. This diverges, and if p is greater than 1, it converges. And that's it. That's all there is to the p-series. So what are some examples? Maybe you have a series like this, where you have, the 1 over the square root of n. If you have the square root of n, that would be the same as having a series in which you have n to the power of 1/2 in the denominator. And if you have something to the power of 1/2, that would mean that it diverges, because 1/2 is certainly less than 1. So you could also have a series of the form where you have something like this, where you have something like this, and so on, where you just have 7 over n squared as your infinite series. If you had 7 over n squared for the sequence in your series, then clearly you will converge, because 2 is greater than 1. It doesn't matter that we have a 7 instead of a 1 in the numerator, because what we really care about is the p-series, which is 1 over n to the power of something. And remember that we could always factor out the 7. So this would converge. You could also have a series like this, where you have addition of 1 in the denominator forever. This is called the harmonic series. So it's easy to guess. It's just 1 over n, because we're plugging in integers into this series. So this one has a power of 1. It has a power of 1, and so therefore it diverges. It diverges because 1 is equal to 1. And if something is less than or equal to 1 in p over there, then it's going to diverge. So that's all there is to the p-series.